Hello world, this is Gold back with another open source video demo. Today I'll be demonstrating single-ended physics joints for JMonkey Engine. Physics joints have existed in JME for a long time, but they've always been what I would call double-ended. Each joint connects two distinct bodies, causing the motion of each body to influence the other. I think Sir Isaac Newton would approve. In contrast, a single-ended joint connects a body to a fixed location in physics space, known as the pivot. You might use double-ended joints to model the links of an iron chain, but if one end of the chain were fixed to a post, it would be natural to model that connection using a single-ended joint, because the post isn't going to move. The Bullet Real-Time Physics Library, on which the JME3 Bullet library is based, has included single-ended constraints for a long time. However, JME3 Bullet never provided access to this feature. As an experiment, I added support for single-ended constraints for Minie, my public fork of the JME3 Bullet library. JME currently supports 6 classes of joints, namely the point-to-point joint, hinge joint, cone joint, slider joint, 6-DOF joint, and the 6-DOF spring joint. Minie offers single-ended constructors for all 6 classes, and today I'll demonstrate all 6. So here's the empty physics space with the axes visualized. Holding down the I key injects round seeds of 4 different colors near the top of the screen. Their initial positions are random, but invisible forces cause them to gather into clumps. Pressing the left and right arrow keys orbits the camera around the y-axis, making the 3D a little bit clearer. Pressing the slash key toggles the app in and out of physics debug mode. Now the seeds appear as magenta wireframes, representing active bodies, and the green arrows represent joints, in this case single-ended point-to-point joints. Point-to-point joints allow jointed bodies to rotate on all 3 axes around the pivot. As seeds are injected into the simulation, they're assigned to 4 different pivots based on color. The joints cause the seeds to form spherical shells around each pivot. Initially, gravity causes them to collect at the bottom of each shell until it becomes too crowded. Pressing F2 resets the simulation and switches to a new test. This one's for single-ended hinge joints. Hinge joints allow rotation on a single axis. Again, there are 4 color-coded pivots, but with only 1 degree of freedom, the seeds form rings around each pivot, which fill quickly. Pressing F3 resets the simulation again, switches to the 3rd test for single-ended cone joints. These have unexplained limitations. The pivot must be at the origin, and the central axis of the cone must be the x-axis of physics space. Since there's only 1 pivot, this test creates seeds that are all of the same color. There's no gravity in this test, which helps clarify that the seeds are collecting in part of a spherical shell that's within a certain angle of the x-axis. F4 takes us to the 4th test. This one's for single-ended slider joints. Again, there's this unexplained limitation that the translation axis must be parallel to the x-axis of physics space. This test creates seeds in 3 different colors, which spread out like beads on a wire, but again constrained to just 1 degree of freedom. F6 switches to the 5th test. This one's for single-ended 6-DOF joints. 6-DOF joints are highly versatile and can be used to simulate other joints. For this test, the translational axes are disabled, causing the joints to behave very much like cone joints. But unlike the real cone joint, the central axis can point in any direction. So I've given each color its own axis. So for instance, the gold seeds are centered on the plus x-axis, and the blue seeds down here are centered on the negative y-axis. F7 takes us to the last test. This one, of course, is for single-ended 6-DOF spring joints. Since this test doesn't make use of the spring feature at all, it's actually indistinguishable from the previous test. All right, we're done with the demo, but in closing, just a reminder that the Minie library is open source. The code resides in a GitHub repository under my GitHub username, which is Stephen Gold, StephenGold. The demo app resides in the same repository, and its file name is SeJointDemo.java. And there it is. This is S. Gold signing off.